Hello friends, in the previous video we studied about solubility and solubility product and solved one type of numericals, okay? And in this video we will study the condition of precipitation and its relationship with the solubility product and ionic product, okay? So we'll study condition of. To understand this, let us take three different solutions of sodium chloride, right? So you have three vessels. The solubility of sodium chloride is 360 gram per liter. Solubility of sodium chloride is 360 gram per liter. So, you see, let I have 350 gram here and each vessel contain 1 liter of water. This also 1 liter water, here also the same. Okay. So, I am adding 350 gram of NaCl here, just 360 gram NaCl here and 362 gram of NaCl here. Okay. So three different cases. When you added 350 gram of NaCl, complete dissociation of sodium chloride takes place. Here, complete dissociation takes place. That means you can add more and you can dissolve more of sodium chloride inside this solution. So this is an unsaturated solution. When you started increasing the amount of sodium chloride into that 1 liter water and just reached adding 360 gram of sodium chloride, so you see this is the case of just saturation, because here also you find complete dissociation. So this is that means this gives you the maximum ion concentration. This gives you the maximum ion concentration because you cannot add. That means you cannot dissolve more of NaCl after this is 360 gram. So this is called just saturated. Just saturated. This is the just saturated solution. Okay now? Now, in case of, when you added more than 360 gram, what happens? 2 gram of NaCl gets precipitated. Why? Because maximum ion concentration of Na plus and Cl minus that can be maintained at a particular temperature is due to only 360 gram. So the rest 2 gram of sodium chloride is precipitated. So when the precipitation occurs, when when the ion concentration exceeds the maximum ion concentration, because the maximum ion concentration is when the amount of sodium chloride is 360 gram per liter. Okay. So this solution, no complete dissociation because 2 gram is precipitated, no complete dissolution or dissociation. Okay. So 2 gram are precipitated. Supersaturated solution called supersaturated solution. Are you getting it now? So, three different cases: unsaturated, just saturated, supersaturated. But whatever is the case, you can maintain the maximum ion concentration And if you exceed that ion concentration, now the precipitation will occur. So, what is the condition of precipitation then? Condition is, you see, the product of ions of the substance in a solution at a particular temperature when the solution is saturated is the solubility product. So this is the middle solution. This has the ion concentration, maximum ion concentration, a saturated solution. At that case, the product of concentration of ions, is called solubility product. We studied in the previous video. So here also, the product of ions can simply be called as ionic product. So before that, ionic product is product of ions of the substance at any concentration. But when the solubility product, this is only when the solution is saturated and ions are at their maximum concentration. So, if we take sodium chloride, the ionic product of sodium chloride can be at any concentration. That is nothing but the product of ions, hence ionic product. And see, here no maximum concentration. In this solution, no maximum concentration of Na plus and Cl minus is present. But yet, their product can be called as ionic product. Since the solubility product is in this case and the mass is 360 gram, so 350 grams of sodium chloride gives a value that will be less than Ksp. So that means product is called the ionic product. In this case, Kip is less than Ksp. Kip is less than the Ksp. And simply, we can well understand, you see, in Ksp, in case of 360 gram, the ionic product, here in this case, Kip is equal to Ksp. In this case, so in 360 gram per liter, the product of ions is equal to product of ions at maximum concentration. So ionic product is equal to solubility product. What that is in this case? You see, here the ionic product, when at the first time you just added, ions concentration is definitely greater than the that means product value of this that means ions at maximum concentration. So in this case, so the product of ions is greater than the product of ions at maximum concentration case, means solubility product. So in this case, Kip greater than Ksp. This is what the condition of precipitation. So condition of precipitation is when the ionic product exceeds the solubility product. Are you getting me now? So this is simple to understand. This can be further explained using an example. Okay. Consider a solution of silver nitrate. Solution of silver nitrate. Okay. So AgNO3 dissociates into Ag plus NO3 minus. So it's a strong electrolyte, and you see silver nitrate dissociates into this type of ions in a solution. So in a solution already there are Ag plus and NO3 minus ions. Now let us add HCl into it, hydrochloric acid. When you add HCl into it, after some addition of H plus and Cl minus, and you will notice that a white precipitate will be there. white precipitate will be there. So why the AgNO3 was not precipitated, whereas on the addition of HCl, a white precipitate was there, right? So what happened? You see, when you added Cl minus, it combined with Ag plus. This Ag plus and Cl minus gives AgCl and precipitated. So why silver nitrate was not precipitated? Because the product of concentrations of Ag plus into NO3 minus, this multiplication value did not exceed the solubility product of HgNO3. But when you added Cl minus, the Cl minus concentration and Ag plus concentration, their compound is the AgCl, and its solubility product is that becomes less than the ionic product. So KIP greater than KSP, hence the precipitation. So as we discussed, the condition of precipitation is ionic product should be greater than solubility product. So that's why AgCl precipitated. Did you get me?